Hi there, this is Math 2, Unit 3, Worksheet number 5, talking about isosceles and equilateral triangles. Remember from today's lesson that isosceles triangles are ones where two sides are equal, which also means that the two bottom angles are also equal to one another. And an equilateral triangle is going to mean that all the sides are equal to one another, which will also mean that the angle measurements inside are all equal. In an equilateral triangle, the inside measurements are all going to be 60 because 60 times 3 is 180, which is the sum total of three angles there. So it says solve for x and show your work. The diagrams are not drawn to scale, so don't worry about the picture too much here. I have, first of all, 5 and a 5, which tells me that this is an isosceles triangle. These are the same. And if that's the same, then this is an x, and this is also going to be an x. So to solve for the value of x, I can recognize that the sum of all three of those angles will be 180, right? So all is going to equal 180. So if I add up 26 plus an x plus another x, it will equal 180. So let's subtract 26 from both sides. All right, so we have over here 10 minus 6 is 4, 7 minus 2 is 5, bring down the 1. 154 is equal to 2x. So now we have 154 equal to 2x, and I just do 154 divided by 2, and we end up with 77 is what our x value is going to be. And in this problem here, I can stop there because I got x, so I'm good to go. I could double check by doing 77 plus my original 26, and I should end up with 180 to prove that that's true. Let's look at number 5. Number 5 is also isosceles. We have two sides of the same there, and the base down here, which is different, which tells me that, again, this value here will also be x, so I'll use the same pattern that I used in the first one. I can say that 180 degrees total is what I should get if I add up 42 plus an x plus another x. So I subtract 42 from both sides. This one goes away, and we have here 138 equal to 2x. I divide both sides by 2, and 138 divided by 2 tells me that 69 is going to be the value of x for number 5. Same idea as number 1. Let's look at number 9. For number 9, we see that I have a 42, a 41, and a 3x minus 1. Okay, so I'm not sure if this is isosceles. It could be, but I know it's definitely not an equilateral because those aren't the same side. But I can find out what that measurement's going to be just to see if maybe it might be an isosceles. It's hard to say without the extra measurement. So let's take what I do know. I know that I have a 56 and I have a 62, and that combined is 118. So what's left? Well, we do 180 minus 118, and what's left is going to be 62 degrees. So if I know that this measurement is 62 degrees, then that tells me these are my two equal angles, that this one equals that one. And if that's the case, then I can set them equal. I could say 42, that value, equals 3x minus 1, and I can solve for x. So I add 1 to both sides, and I get 43 equals 3x, and I divide both sides by 3. 43, yep, divide both sides by 3, and I have x is equal to, and I have 14.3 going on forever and ever and ever. Is that going to be right? Well, that's what I'm getting here, and I think you have some different kind of answers this year in your books, which is kind of nice. So I believe you want to say 14.3 going on forever and a day is what you have. Let me double check my work because it seems to be different than a traditional answer. So 56, 8, 111, 180, 10 minus 8 is 2, 7 minus 1 is 6, 62. Matches, matches. I'm isosceles this way, equal, equal. So I set that equal to that one, and there we go. So 3x minus 1 should be equal to 42. We added 1, 43, and yep, that's what you get. So kind of a strange, different answer. We're used to whole numbers, but today it's a little different. No problem. Let's take a look at number 12. Number 12, We have isosceles here because it's 10 and 10, which tells me if that's x, this is also an x. And so I'm back to what I did with numbers 1 and 5. I have 180 degrees total inside of the triangle, and they gave me a 53 plus 2 x's, 1, 2. So I subtract 53 from both sides, and when I do that, I have 127 equals 2x. Okay, so 127 equals 2x, and when I do 127 divided by 2, I end up with 63.5 is equal to x. So I get a nice little decimal there for that one there. And that's what I got. Again, check your answers, work with a partner, check with a neighbor, check with your teacher ultimately to see if you're doing it right. That's some examples of the first page. Let's look on the second page here. It says first you have a proof, and I'm not going to do that one. We did a lot of proofs last few days, so I'll let you review your work to get that one figured out. But 14, same idea. We have solve for x, find the perimeter of the triangle, and classify the angles. So we're solving for x, find the perimeter, and classifying it. 3 things here. So first of all, I can see that I have a 13 and a 13, which tells me that this is going to be an isosceles triangle. So I can write that down to begin with. Isosceles, right? Because I have 13, 13, 10. If that's isosceles, then this makes that angle measurement 75. So I have a 75 plus another 75 plus the x value is going to equal 180. All right, and 75 plus 75 is equal to 150 plus x equals 180. I subtract 150 from both sides, and what remains is x is equal to 30. So we can say x is equal to 30 degrees. In terms of the perimeter, I'm going to add up all the sides. 13 plus 13 plus 10. 13 plus 13 is 26, plus 10 is going to be 36. And that's the idea for that one. You do something similar for number 15. We can see again we have an isosceles just turned on its side a little bit. And now let's take a look at number 16, kind of our last one here we're looking at today. We have here a triangle made from a couple of lines going this way, and so we know that we have measurements here, here. We don't have one there, except that if I remember from previous lessons, this is a vertical angle, which means that that measurement is equal to that measurement. So with that being said, what I really have is I can say that 8x minus 44 plus 3x plus 21 plus 5x minus 5 all are going to equal 180. Nice long problem there, isn't it? Okay, so we combine our like terms, 8x plus 3x and a 5x. So 8, 9, 10, 11, 12, 13, 14, 15, 16x. Got that there. Then I have a negative 44, a positive 21, and a negative 5. So you want to do that. Negative 44 and negative 45 is a negative 49. I have another 21, so I can subtract that and then get the difference. So I have negative 28 is what I have there when I combine all those together. And then I have it equal to 180. I can add 28 to both sides. And we have 16x equals 208. I can divide both sides by 16, and x is going to equal 13. Now I'm not done, that's just the value of x being equal to 13. It does say to classify the triangle. I don't have enough information yet. In order to classify a triangle, I need to find the angle measurements themselves by plugging the value of 13 back into these shapes. So let's plug it back into this one first of all. I have 3 times 13 plus 21. Well, 3 times 13 is 3 times 13 equals that, plus 21 is equal to 60. Alright, and then our other one is 5 times 13 minus 5. Let's try that. 5 times 13 equals that, minus 5 is 60. Now so far, if I have a 60 and a 60, this one has to also be 60, but let's prove it real quick. Let's do 8 times 13 minus 44 and see what we get. 8 times 13 equals that, minus 44 equals 60. So because I have three 60-degree angles, we would classify this triangle as an equilateral triangle. And that's the idea for that one. I'd recommend just looking at number 17. 17, spend some time with it, okay? It was a little bit interesting, a little bit of a challenge. As I worked through this, the numbers I was coming up with didn't quite seem to play out. So I may have been missing something. Maybe there's a wrong number on there. I'm not positive. I kept coming up with a negative answer for x, and that's not going to be right. So I'm not sure. So I have a question mark on that one. So I would definitely say check with your teacher to see if those are the right numbers for that shape and how that one's solved. It's a great question. If you find out, let me know. Thanks. Have a great day.